Galaxies, from swirling spirals to ancient ellipticals, hold the secrets of the universe. In this video, we'll dive into 20 practice questions to help you in space and astronomy Olympiads on galaxies and galaxy clusters. Some are easy, some will challenge you. Let's begin with a very simple one. Which type of galaxy has a flat, rotating disk and often features spiral arms? A. Elliptical, B. Irregular, C. Spiral, D. Lenticular. Let's find out the answer. The correct answer is C. Spiral. These galaxies rotate and often have well-defined arms. Next up, let's test your concepts. Explain the difference between a Baird spiral and a normal spiral galaxy. A Baird spiral has a straight bar of stars cutting across its center. Spiral arms emerge from the bar, not the core. Normal spirals lack this bar structure. Let's test your galaxy knowledge with a size showdown. Which of these is the largest type of galaxy by physical size? A. Dwarf, B. Spiral, C. Irregular, D. Elliptical. Think spirals are the giants of the cosmos? Think again. The correct answer is D. Elliptical. While spiral galaxies like the Milky Way are large, elliptical galaxies can be enormous, with some spanning over 1 million light-years across. They are typically composed of older stars, have little gas or dust, and are the most massive and extended galaxies in the universe. Here's a tricky one. Why do elliptical galaxies appear red and lack star formation? This one's all about stellar evolution. Here's the explanation. Elliptical galaxies contain mostly older stars, with very little gas for new stars to form. They are also called red and dead galaxies. Let's zoom way out, beyond galaxies and clusters. The Milky Way is part of a giant supercluster with a diameter of 160 megaparsecs. What is the name of this supercluster? That's over 500 million light-years across. So what do we call this immense region of the universe? If you answered Laniakea supercluster, you're on the right track. Good job! The name Laniakea means immense heaven in Hawaiian, and it includes the Virgo supercluster, Hydra Centaurus, and several others. This structure contains over 100,000 galaxies, including our very own Milky Way, and redefines the boundaries of our local cosmic neighborhood. Here's a galaxy that sits between two worlds. Lenticular galaxies are considered a transitional type between which two major galaxy classifications? A. Spiral and irregular, B. Elliptical and spiral, C. Irregular and elliptical, D. Spiral and dwarf. Let's find out where they belong. The correct answer is B. Elliptical and spiral. Lenticular galaxies, classified as S0, have a central bulge and a disc-like spirals, but lack prominent arms and contain older stars, much like ellipticals. They're often thought of as evolved spiral galaxies that have used up or lost most of their gas, halting star formation. Let's bring it a little closer to home, cosmically speaking. What kind of astronomical object is the Large Magellanic Cloud? A. Constellation, B. Dwarf galaxy, C. Nebula, D. Galaxy cluster. You were right if you chose B. Dwarf galaxy. The Large Magellanic Cloud, or LMC, is a satellite galaxy of the Milky Way, located about 163,000 light-years away. It's a dwarf irregular galaxy that contains stars, gas, and even the famous Tarantula Nebula, one of the most active star-forming regions in our galactic neighborhood. Now for a question that's a bit disorganized, just like the galaxies we're talking about. Why do irregular galaxies have such chaotic shapes? Let's see how you did. Irregular galaxies often have chaotic shapes because they've been gravitationally disturbed. These distortions can happen due to close encounters or collisions with other galaxies, tidal forces, or even internal bursts of star formation that push gas and stars around unevenly. Without a stable structure, they end up looking asymmetrical, clumpy, and scattered, earning the name irregular. Moving on, which of the following is not a real galaxy? A. Whirlpool, B. Pinwheel, C. Pegasus, D. Sombrero. The correct answer is C. Pegasus. While Pegasus is a constellation in the night sky, it's not a galaxy. The other three, Whirlpool, Pinwheel, and Sombrero, are all names of well-known galaxies. What is the name of the diagram used to classify galaxies based on shape? A. Hertzsprung-Russell diagram. B. Hubble tuning fork. C. Chandrasekhar limit. D. Messier chart. Let's check the answer. B. Hubble tuning fork. This diagram groups galaxies into ellipticals, spirals, and barred spirals based on visual structure. Now here's one about appearances. Elliptical galaxies are labeled with an E followed by a number. What does that number represent? A. Size of the galaxy. B. Color index. C. Degree of flattening. D. Number of satellite galaxies. The correct answer is C. Degree of flattening. The more stretched it is, the higher the number. Let's decode the label. E0 is nearly spherical, while E7 is very elongated. Trying answering this one, true or false. In the Hubble tuning fork diagram, younger galaxies are located on the left and older galaxies are on the right. Correct choice is false. Elliptical galaxies, found on the left, are generally composed of older stars and have little star formation. Spiral galaxies, located on the right, contain younger stars and show active star formation, especially in their arms. Zooming into spirals now. In Hubble's system, what does the sequence SA, SB, SC describe? A. Increasing age. B. Increasing bulge size. C. Increasing gas content and arm looseness. D. Increasing redshift. They're all spirals, but what's changing along the way? The right option is C. Increasing gas content and arm looseness. SA galaxies have tight arms and large bulges, while SC galaxies have loose arms and smaller bulges. Next question. What does the SBB classification in the Hubble system refer to? A barred spiral with tightly wound arms? A highly flattened elliptical galaxy? C. A ring-shaped irregular galaxy? A galaxy in the Virgo supercluster? The answer is A. A barred spiral with moderately tight arms and medium-sized bulge. SBB lies midway in the barred spiral sequence, between SBA and SBC. Here's a subjective one. Briefly describe the structure of a typical spiral galaxy. Think carefully. Take a moment to lock in your answer. Let's find out. A spiral galaxy has a central bulge with older stars, a flat rotating disk containing spiral arms rich in gas and young stars, and a halo surrounding it made of old stars and globular clusters. Most also have a supermassive black hole at the center. Let's keep going. Which of the following is a known interacting pair of galaxies? A. Triangulum and Pegasus. B. M81 and M82. C. M87 and Andromeda. D. Whirlpool and Milky Way. Answer B. M81 and M82. These two galaxies gravitationally influence each other and show signs of tidal interaction. Next, a question on telescope that helps us explore galaxy. Which space telescope provided deep field images that revealed thousands of distant galaxies? A. Chandra. B. James Webb. C. Hubble. D. Kepler. Answer is Hubble. The Hubble Deep Field and Ultra Deep Field images showed galaxies billions of light years away. Next up, on types of galaxy clusters. What are globular clusters primarily made of? A. Dust and gas. B. Young blue stars. C. Old stars. D. Neutron stars. The correct answer is C. Old stars. Globular clusters are tightly bound, spherical collections of ancient stars, often over 10 billion years old, and they orbit the outer halos of galaxies like silent stellar fossils. Can you name 2 galaxies in the local group besides the Milky Way? The local group of galaxies consists of 3 large galaxies: the Andromeda Galaxy, biggest, our Milky Way, second biggest, and the Triangulum Galaxy, third biggest, along with 50 or so much smaller dwarf galaxies. Let's end with, what are starburst galaxies? Starburst galaxies are galaxies undergoing intense star formation at a rapid rate, often triggered by collisions or mergers. Galaxies are more than just star systems. They're the building blocks of the cosmos. If you love this quiz, like and subscribe for more Space Olympiad prep, and tell us in comments, how many did you get right?